Hey everyone, welcome back to the channel. Today, we're tackling LeetCode problem number 3, longest substring without repeating characters. This is a classic problem that often shows up in coding interviews, and it's a great way to learn about string manipulation and algorithm optimization. The problem statement is simple. Given a string, find the length of the longest substring without repeating characters. For example, if we have the string ABC, ABCB, the longest substring without repeating characters is ABC, which has a length of 3. Another example, BBB, the longest substring is just B, with length 1. We'll be focusing on a dynamic programming approach to solve this efficiently. Seems straightforward, right? But there are some interesting nuances we'll explore. Get ready, let's dive in. Understanding with examples. Let's solidify our understanding with a few more examples. Consider the string PWKEW. The longest substring without repeating characters is WKE, with length 3. Notice that PW is also a substring without repeating characters, but it's shorter. Now let's look at DVDF. The longest substring is VDF, length 3. See how we're always looking for the longest substring that doesn't repeat any character within itself? It's crucial to understand that the characters can be non-consecutive within the entire string. It's about the substring itself. Let's take ABCABCB again. We identify ABC as the longest substring without repetition, even though ABC appears twice in the input string. This is key. We're focused on the longest consecutive substring, not the longest overall. Feeling comfortable with the problem statement? Great. Let's move on to the brute force solution. Brute force approach. A simple brute force approach would involve checking all possible substrings within the input string. We'd iterate through every starting index, and for each starting index, we'd iterate through every possible ending index. For each substring, we'd check if it contains repeating characters. If not, we'd compare its length to the current maximum length and update it accordingly. This approach, while straightforward, is very inefficient. Its time complexity would be O of n cubed, because we have nested loops, one for each starting point and one for each ending point, and then another check to see if we have repeating characters. It's not ideal for larger input strings. Let's explore a much more efficient approach using a sliding window technique, which falls under dynamic programming. Optimal solution. The optimal solution leverages a sliding window. Imagine two pointers, a left and a right pointer. Initially, both point to the start of the string. The right pointer expands the window to the right, adding characters. As we add characters, we check for repetition using a set to efficiently track scene characters. If we encounter a repeating character, we move the left pointer to the right to shrink the window until the repeating character is outside the window. The maximum length of the window during the process represents the longest substring without repeating characters. This clever approach drastically reduces the time complexity, a significant improvement over the brute force method. Let's visualize this with an example and then see the code in action. Code implementation. Let's see the code in Python. We'll use a set to store the characters in the current window, and two pointers, left and right. We initialize the left pointer to 0 and the right pointer to 0. We iterate, expanding the window with the right pointer, adding each character to the set. If we find a character that already exists in the set, it means we have a repetition. Then we move the left pointer to the right, removing characters from the set until the repeating character is no longer in the window. Throughout this process, we keep track of the maximum window size, which represents our final answer. This dynamic approach is both intuitive and efficient. We will make sure to add comments to make the code easy to understand and follow. Here's the complete Python code. Time and space complexity. Now let's analyze the time and space complexity. The time complexity of this sliding window approach is O of n, where n is the length of the input string, because we process each character at most twice, once with the right pointer and at most when the left pointer moves. The space complexity is O of min m, n, where m is the size of the character set, which is 256 for ASCII characters in this case, and n is the string length. because the maximum size of the set will be at most the size of the alphabet used in the string or the length of the longest substring without repetition. This optimal solution represents a significant improvement in efficiency. We've gone from O of n cubed to O of n, a very noticeable upgrade. Engagement break. So, we've conquered the longest substring without repeating characters problem. Before we wrap up, I'd love to hear your thoughts. Did you find this explanation helpful? What other LeetCode problems should I tackle next? Don't forget to like this video if you found it useful, and subscribe to the channel for more coding tutorials like this. And if you have any questions, leave them in the comments below. I'll be sure to answer them. Let's keep this learning community growing together. Conclusion. To recap, we've explored the longest substring without repeating characters problem, understood its nuances, implemented a brute force solution, and then moved on to the optimized sliding window approach using a dynamic program.